Hey guys, I'm the developer of Rally Racer. This is a work in progress. I've been working on this for just over a month now, and I'd like to show you a little bit behind the scenes. I made this game with Corona SDK, and one of the tricky parts of making this game, it's a top-down racing game. I'll give you a little demo right here. This is what I have been working on. So yeah, so you get that. So what we're first going to look into is how I got the user's car to move and drift around the track. So if we go over here to um, our code, this right here is inside a runtime function that is called every single frame. And so we have an imaginary dot around a center point. And when the user turns the car left or right, they touch the left or right side of the device. It will change the orbital speed. We'll rotate the orbital, and then we can do some math, trig, to find out the delta, because we can make a right triangle out of that, and then we can find the angle, because this is in radians, so we got to get it back into the angle, because Corona uses a angle degree system. And so then one of the hard parts about this is knowing how to apply the delta values to the car. And so what I found is that applying a force to the car is a physics body. It works really well to get it to drift around the track. Now if you don't want drifting, you can use set linear velocity, which is much more rigid. But I did have some problems when the car hit some other physics objects. So that's why I'm leaning towards using apply force. So it just wants the x and y delta values, which I have right here. And then it's just applying the force to the center of the car. Okay. Now get this back up. Oops. Let's put it back here. If we keep playing, you can use this to control the car for a bit more precise maneuvering. It is lag performance on the device. Okay, now that you get a sense of that. Now the next topic we're going to talk about is how the computer car to go around the track. Now I debated many different options for this, and I eventually just went with using, I raced the normal car, the user car around the track, and I logged its coordinates and its rotation value. And then the AI car reads from that table that I saved. Because Lua can, there's a library that converts the JSON to a Lua table. And so that works very well. One of the downsides of that is that it's very rigid. So it's not completely realistic, but for the style of game that I'm going for, I thought it was okay. So if you see right here, let me find it. Oh, we're getting a little bit of. Okay, here we go. So in order to make the AI car movement smoother, I attached it to a touch joint, and then every frame I pull from the saved JSON file the coordinates, and I plug them into the target for that joint, and then the car will smoothly go around and follow it. Let me get this back here. And so yeah, and then the rotation is also just pulled directly from the the file. And so an advantage of this is that the car it behaves a lot like a human would, since I drove it around by myself. It's not following like a Bezier curve or anything. So yeah, for the smoke you're seeing and the drift marks, I did not know that Corona had a physics particle emitter built in, so I had to kind of make my own. Wasted a lot of time doing that. Just adding rectangles and circles into a Lua table, and then 10 seconds after you're fading it out to alpha equals 0, and then removing it. Looks like complicated, it's really not. So yeah, um, please subscribe. I know this is the first time I've made a video in a very long time, but I plan to make them much more often, and I really think this game is going to be awesome. So it's going to be free, don't worry. So yeah.